What's up everyone, Justin with the Fabrication series along with weldmetalsonline.com with a quick guide of everything you need to know in order to set your TIG welding machine up and get welding. Season 5. Now first things first, before we even go into turning the machine on, there's something we got to look at here. This is my Everlast Power Tig 255 EXT. It is the most powerful machine I have here in the shop currently. It is a total beast of a welder, meaning that it welds everything. It's jacked full of features, and it's a real pleasure to use. I absolutely love it ever since the day that I bought it. Next to it, we have the Everlast Power Tig 185 DV. It has a lot less features, a few less amps, and definitely has a much more affordable price tag. But is there a difference between these two machines? What about this one? The AHP Alpha Tig 200X. This is all analog control, is delivered to your door for less than $800, and it's a very popular beginner welding machine. Now, regardless of which machine you have, regardless of the price tag, regardless of the features, regardless of the brand, they all have one thing in common with each other: the electrode polarity and orientation. The electrode in TIG welding is the tungsten. The tungsten is housed inside of the torch. Ergo, the torch is what most people reference when we're talking about polarity and orientation, which will be the exact same on every single TIG welding machine. Now, certain metals like steel, stainless steel, titanium, and even chromoly are welded using DC electrode negative, or DCEN, direct current electrode negative. That means the torch will always be installed into the negative port. While there are hacks, tricks, and a whole lot of misinformation out there about welding in DC electrode positive, there is no reason to use DCEP when TIG welding. The torch will always be installed in the negative port. Even when welding in AC, the torch will still be in the negative port. There is no reason to put the torch in the electrode positive port to weld DC or AC. If you do install it in the positive port, you'll see your tungsten melt away and disappear very violently, and your balance settings on AC will be backwards. Again, there is absolutely no reason to install the torch into the positive port. The torch, or the electrode, goes in the negative port, which means the ground clamp, or the earth lead, goes in the positive port. Now, some machines won't even let you switch those two around. They're almost always static in the negative port for the electrode, and maybe the positive port or the ground lead is hardwired into the machine. You can't even switch them. If that's the case, you don't even have to worry about that, and it's always going to be an electrode negative orientation. This right here is the electrode negative orientation, and this will be the exact same across all TIG welding machines. They never ever change. Now, amperage is one of those kind of confusing topics for some people. Now, generally we follow the rule of 1 amp per thousandth of an inch of material thickness, or 40 amps per millimeter. Now, something like a scratch start TIG, maybe a lift start TIG, or if you're programming 2T and 4T operations, the amperage you set on the machine is the amperage you get. Now, if you have something like a foot pedal, for example, you have a variable amperage controller, which means you have complete control over the output of the machine. It also starts and terminates your arc. Now, the foot pedal is actually really simple. The more you step on it, the more amperage you get. The less you step on it, the less amperage you get. But the confusing topic is about that maximum output at full pedal. Where do you actually set it? Now, one common belief is that amperage on the machine is completely irrelevant since you have all that control in the foot pedal. So might as well just max it out. Well, that's actually kind of a bad idea, especially in the beginning. And to tell you the truth, in all of the years that I've been TIG welding, I still don't max out the machine unless I need maximum amperage. The reason why is actually very simple. The pedal will max out on whatever you set your amperage on the machine to. So if you dial in 100 amps, your full pedal output will be 100 amps. If you set the machine to 200 amps, your full pedal output will be 200 amps. Now, if you only needed 100 amps from a maxed out 200 amp pedal to weld your part with, you'll be operating within only the first 50% of that pedal, and your accuracy is decreased. It's literally a guessing game since you can't see the machine while you're welding. Just remember that 5 amps will make or break a weld. Now, if you have a pedal that is loaded with 200 amps and you're trying to hit that 5 amp sweet spot, you're working in an area this big. Now, on the opposite side of that one, if you're working in your proper range, let's say 100 amps, hitting that 5 amp sweet spot is going to be about this big. That's a lot easier to hit than that one. So make sure that you have your pedal dialed to the actual rule, or the maximum amperage that you want on there. Don't max the thing out. Remember, you have all the control in the world, so it's best to put it with the most control at your foot so you get the best weld. Okay, moving on. Heat. This is something you've probably heard me say a handful of times, and you're definitely going to hear me say it again. Heat has nothing to do with your amperage. It is all relevant to time. The more time you spend on your part, regardless of the amperage, the more likely you're going to cook your part. But you will definitely be adding more heat if you are too low on your amperage or too high on your amperage with too low of a travel speed. Travel speed is your time, right? There are other factors that go into this thing like torch height and stuff like that, but we're going to get into all of that, trust me. But you have to put this into your head, the very simple fact that if you spend more time on your part, regardless of the amperage, more time equals more heat, period. Now, one thing you have to understand is that amperage is what you're going to need to set just right in order to get through this. Now, there are techniques that you can use to like modulate your foot pedal and work it one way or the other and stuff like that. But without that initial skill or understanding of the amperage or being able to use your amperage to get through it, yeah, well, it's not one of those things you really want to go chasing out in the beginning. It's more of a developed skill, something that you're going to want to have eventually. But right now, you need to focus on the fact that you need the amps in order to get through it. So if you come in too low on your amperage or too high on your amperage with too low of speed, well, you're definitely going to cook your part. Here is a very simple exercise that you can actually try out yourself. This is one carbon steel coupon, 1/8 inch thick from weldmetalsonline.com. They come in a pack of 10. I like to have them in the toolbox or at the ready whenever I want to practice on something before I get to actually welding it. But let's look in close here. I'm just going to make a couple of spot welds here. One of them I'm going to go at the recommended 120 amps. The second one, I'm going to drop it down to 100 amps. Both of them are going to be done with this number 5 cup. The number 5 cup is pretty standard. I have about 12 CFH running out of it, and as soon as I make the first spot weld at 120 amps, which is the recommended amperage for the thickness on this one, then we'll let the post flow run, the whole works. I'm just going to make a spot weld. Any size will do. You can also do this at home. Right about there should be good. Okay, now I'm going to go turn the machine down. Okay, the machine has been set back down to 100 amps now. We started with 120, now we're at 100. I'm going to try and match the same size of spot weld on this one. Full pedal the entire time the same way as I did it the first way through. I'd say about there. Okay, look at the both of these side by side. Notice one very important thing. The lower amperage is hotter than the higher amperage. How do I know that? There's a lot more heat signature that's forming around this one than there is on this one. The fact of it is we spent more time making this one do the same as this one. That's what made it hotter. The more time we have in it, the hotter it's going to get. Now you might just think in the beginning here that the best idea is just to add more gas to cover that, so that way you won't get so much color. Well, to tell you the truth is, that's one of the more confusing parts and definitely a problem in the beginning. So let's talk about the gas and consumables. Once upon a time, TIG welding used helium. Now we use 100% argon. We do not use CO2. We do not use argon CO2 mixes like we do in MIG welding. We do not use oxygen. We do not use hydrogen. We do not use acetylene. We do not use any of that stuff. We use 100% argon. That's it. Now, this is where it gets a little bit tricky here. There are specialty gases. There are things that will increase your deposition rates, increase your efficiency, increase the general appearance, will make you weld faster, make you weld, whatever. There's things that the specialty gases will do, but the fact of it is they will not increase your welding skill. They will not make you weld better. They will not make you weld prettier. They will absolutely destroy your weld the exact same as 100% argon if you don't have a skill to use that gas. They are not there to make you weld better. They're just there to make better welders or established welders with the skills weld more efficient or achieve a certain purpose. So don't fall for that I need argon and helium or whatever to weld aluminum and stuff like that. I can tell you straight up, the only thing that you're going to lose on that one is money, and you're going to gain a lot of frustration. So remember, 100% argon, that's all you need. The rest is skill. Once you have the skill, you can get going. You can move on, just like we're going to do. TIG torches and consumables. Let's talk about these for a moment. There's a lot to be said about TIG torches, and they're actually very confusing because not one bit of that numeric system that they use to note which one is which and what they do and what their amperage rating and all the rest of the stuff makes absolutely no sense whatsoever. But we have a dedicated video all about TIG torches. In fact, that's the name of the video, all about TIG torches. You can check the video card, the description, the whole works, and you can see everything you need to know about TIG torches in order to get going. But what we need to focus on right here is the consumables itself. More specifically, the lenses, the cups, the gas lenses, all the rest of that good stuff. Now, whatever torch you have, flat out, if you like it, use it, nothing's wrong with that. But I'm going to suggest that you stay away from those like $12 TIG torches you see on like Amazon or eBay or anything else like that. I mean, because they suck. I mean, just don't expect a lot out of them. If you want a good torch, probably one of the best brands out there, I'm going to suggest CK Worldwide. This is not a paid endorsement or anything else like that. I have several CK Worldwide torches that I use regularly, and I absolutely love the product. So, you know, use whatever you want, but if you want to go for the top there, CK Worldwide is the way to go. Now, as far as consumables go, you're going to find a lot of people suggesting that you use gas lenses. You're going to find a lot of people suggest you use larger cups. You're going to find all kinds of other stuff. But I might be the weirdo on this one that might give you the best piece of information you ever had on this, and that is use the standard consumables. In the beginning, I always suggest using standard consumables. Those are things like small diameter cups. Those are things without gas lenses. Those are not things like unicorn fart makers of the 16 BBW Michael Furick cup, or even the number 12 Furick cup, or even a number 8 with gas lens. These are specialty cups. These are for increasing or enhancing your existing skill, not for developing your skill, because they will hide everything that you need. Now, things like trailing cups, back purge fixtures, and all kinds of other stuff, they will do the exact same thing. They are not to make you weld better in the beginning. They are to increase your existing skill or to be used as a tool and not a crutch. Let's just move on to an example of that, because I think I have exactly what you need to see. I'm going to repeat this test, the same one as I did before with the small consumables, but this time I put a number 12 FUPA cup on there with the proper amount of stick out, 120 amps, and now with 30 CFH of gas flowing out of this with a ton of coverage. So let's just see what it does. 120 amps, full throttle. Spot weld. All right, let's turn the machine down. This is 100 amps, full throttle. I'm going to match that spot weld the same as I did before. That's about right. That's fine. But you notice one very important fact on this one? Neither one of these has any color whatsoever. I'm going to make 3 welds on 2 different coupons. The first one I'm going to do is a number 5 cup. That number 5 cup will be run at 120 amps, which is the proper setting for the thickness that we're welding, with all correct settings, all skill. The second weld I'm going to make with just a little bit less skill, too high of a torch height, but still 120 amps. The third weld I'm going to make is with too low of amperage, 100 amps. Then I'm going to repeat the same test with a number 12 cup and lots of gas coverage. 120 amps in the first weld, 120 amps in the second weld with a high torch height or improper skill, and 100 amps on the final weld. Now let's take a look at the results. You notice that the first weld on each one of them, 120 amps, proper skill, good torch height, good travel speed, both of them netted nearly the same result. Now the termination of our weld on the number 12 cup netted a much better result, as in less color. But at the same time, there is no difference between this weld and this weld. Both of them were welded proper, and both of them will pass. One of them just has less color, but the heat affected zones, everything else that we're looking at, is dead on. That's what we need. However, if we run over to improper skill, just a little bit too high of a torch height, notice that the number 5 cup showed us that we are way too friggin' hot. It also has not the greatest reveal on it. It's a little grainy looking, it's a little hazy, and our heat signature is dramatically increased. It's massive. In fact, the color bled all the way out to the edge. Whereas when we look at the number 12 cup, well, guess what? It's a little more contained. It was the exact same weld for the most part, as much as I could do to match it, but even though this looks like a passing weld, take a look at the leading edge of that puddle. You can see right here, we have a bit of a hole, a pinhole that goes into the end of it. And on the number 5 cup, we have a pinhole and it shows us a lot of heat. The number 12 hid the problem that we have too much heat, which is associated with torch height. This looks like a just perfectly fine weld. Now finally, we run too low on the amperage. Look at the number 5 cup. It definitely shows us that we're too low on the amperage. Look at all of that heat affected zone. That's a little bit too much. That was a 100 amp weld. Too low, too slow. On a number 12 cup, it doesn't look too bad. Looks like it'll do. Obviously we have excessive heat, but you know what? It looks a little bit prettier. It looks like it'll do the job. It looks like it'll be good. But hidden underneath is the problem. Now apply that to stainless steel. Now hopefully that makes enough sense to you guys that you can understand that standard consumables are probably the best thing that you could ever start with running. This is a number 5 cup. You can use number 5, number 7, but again, no fancy gas lens, no big giant cups and all the rest of that stuff. Now I'll be honest with you, they are gratifying. It is really nice to see some great rainbow puke all over your welds, no color and all the rest of that good stuff. But you can see that they will definitely hide the problem. They will not show you what you need in order to improve upon your skill. Remember, we used cups like this for decades, absolute forever, until the gas lenses came out and all the rest of that good stuff. And while I absolutely love the whole Furic lineup, it's really important that you avoid it in the beginning because they will not show you what you need to know in order to improve upon your skill. So in the beginning, stick to the discipline. When you can weld it without the fancy consumables, then and only then can you switch to the fancy consumables. When it comes to argon flow rates, people tend to get a little confused. Now I only suggest that based on posts that I've seen on social media groups and the questions and stuff that people have submitted to TFS, needing help on stuff. Now, there's a very simple formula that you can follow. Actually, it's ridiculously simple. You don't even need a cocktail napkin to do it. Take the diameter or the number of the cup, multiply it by 2, there is your minimum flow rate in CFH. Same thing works with a large cup like a number 12. Multiply by 2, that's 24 CFH at minimum required to run this cup. Now Michael Furic recommends that you actually run this at 25 to 35 CFH per the instructions that come with this cup. Now that's fantastic, that'll definitely get you in the ballpark, and if you need to bump it up a couple of points, bump it up a couple of points. But let's see if that rule holds true. Here is a number 5 cup at 10 CFH. Here's one at 12 CFH, and here's another at 15 CFH. The only difference you're going to find is the amount of time you spend welding in between cylinder swaps. We'll look at these in a second, but let's actually do something kind of extreme here. Let's push a number 5 cup with way too much gas and see what happens. Here's that same number 5 cup at 20 CFH, and here it is again at 30 CFH. But just for fun here, let's take a number 12 cup and run it at 12 CFH, a little bit too low. Now I should remind you, this was all done with skill. We were working with super tight torch height, 20 dabs each every single weld, and we were combating anything that we would normally combat that we would learn how to do. Now if you don't have that skill, you're probably going to see some differences in the higher number ratings, and of course the 12 on 12 here, which even with skill, I encountered a problem. The puddle was just a little bit wide there, and it was a little bit of a trouble to work with, and of course we got some gray hazy areas on here. However, the 5 on 30 and the 5 at 20, both of those would probably give you some fits because there's a lot of turbulence and stuff like that that could flow and introduce atmospheric gases. So I was really scooting through that. But I mean, listen to this thing actually flow here. This is ridiculous. Now you notice at the end of the day that the 5, the 12, the 15, the 20, and the 30 look exactly the same, which means this one costs more to run than this one, and this one at 10 CFH runs just fine. That means that the rule of the diameter times 2 or the cup number times 2 absolutely holds true. Don't waste your argon. Don't waste your argon. Finally, let's talk about some tungsten real quick. Now, this is a super sensitive subject. For whatever reason, people don't seem to get along when it comes to tungsten, right? We'll just put it that way. Now, let me just make it as very clear as possible. Tungsten will not make or break your weld. There is no such thing as a tungsten that will make the weld all perfect, and it's the one that everybody has to have. It's literally preference. It is a super sensitive topic, so tell you what, whatever tungsten it is that you think you weld best with, use it. Stick with it. Try some different ones to make sure that, you know, one's good, one you like, one you don't, whatever the case is. Try a bunch of them. But here's some other little cool things about this one. In the beginning, you're going to eat up a lot of tungsten. You're going to go through it regularly, religiously, if you will. But if you want to save yourself in between, you know, times that you have to sharpen or whatever the case is, take one piece of tungsten, chop it down into threes, sharpen one side and one side only. Now, one pack of 10 turns into 30, and guess what? You can weld for a lot longer and spoil up all the rest of them and then sharpen them all at once. This gives you time to kind of cool down, relax, because in the beginning, of course, welding is extremely frustrating. So take one piece, chop it into threes, you get 30 pieces of tungsten to actually make a run with or a session, and you're good to go. One thing additionally that I'm going to mention about tungsten here is very, very simple. We have an episode all about tungsten stick out, how it works best, and all the rest of that good stuff. But in the event that you decide you don't want to run with that one or actually check that one out, take the number of the cup. This is a number 16 cup, which is 16/16 of an inch or 1 inch. That number of the cup is the maximum allowable stick out that you can operate on with the typical CFH. You can run a little bit more, you can run a little bit less. You don't always want to run less because you can't always see it, but at the same time, 1 inch of stick out on a number 16 cup. 3/4 is a number 12 cup. That's 3/4 of an inch of stick out. 5 is 5/16, which means 5/16 of an inch of stick out. It's very, very simple. So that's something you need to check out. I encourage you to look at that video and all the rest of that good stuff. As far as tungsten goes, let me just break it to you simple. If your machine was made before like 1995 and it just happens to be like an old transformer machine, then you can actually stick with like the green pure tungsten for aluminum and whatever other color you want to use for DC, and you know, go from there. So that is going to wrap it up for this episode. I want to thank you guys for watching as always. Also, a very special thanks to weldmetalsonline.com for providing the metal used in this episode. Definitely go check them out. Really appreciate it. Now, if you need to get in contact with us, hit us up on the fabricationseries.com website, Instagram at the.fabricator, or facebook.com/thefabricatorseries. If you got any questions or comments, go ahead and drop them down in the comments box below. We'll definitely try to get back to you, but please do check out the other videos if you have a question that we didn't necessarily cover in this one. We've got a lot more coming up on the future episode list about every single metal and how to weld it in that great detail and all the rest of that good stuff. It's already in the works. We're just waiting to get them out there. So I'll catch you guys on the next episode. Thank you as always for watching.